Friends, today we are going to talk about a very basic topic, a very important invention which took place in 1929 by one American physicist whose name was Robert J. Vandegraaff. He used a basic concept of electrostatics. He used the idea of electric potential. He used the collection of charges at one point and invented an extraordinary electrostatic machine that we are going to talk about, that is Graaff Generator. In this video, I am going to talk about complete details about Graaff Generator. First, I am going to talk about dome. Then after, I am going to talk about the belt and brushes, spray brush and collecting brush. And after that, I am going to talk about the functions of these brushes and belt. Then going to talk about where this Graaff generator is enclosed, and also going to talk about why we are going to use some special gases inside this Graaff generator, and working of Graaff generator and applications of Graaff generator. One more important thing, the heart of Graaff generator is particle accelerator, which is also called as the discharge tube. So I am going to talk about the working of discharge tube and how particles gets accelerated inside this particle accelerator. So let's start today's topic, that is Graaff generator. Graaff generator help us to understand basic principles of electrostatics. It helps us to understand how we can produce high voltage, high potential by using basic principles of electrostatics. Let us understand how such a simple device can produce high energy charged particles, and the second one, how the charged particles will have energy of the order of 10 million electron volts. The very important part of Graaff generator is the spherical surface, the spherical hollow sphere at its top. In this hollow sphere, which is also called as a dome, in this hollow sphere, the charge continuously added up. The spherical dome is polished and it is supported on an insulating column. Now, important question, why dome is polished surface? The answer is, it is polished to prevent leakage of electric charge to air. If it is not polished, due to rough surfaces, there may be leakage of electric charge to air due to corona effect. Now, we use silver polish or autosol for polishing the dome surfaces. Now, next question, why dome is supported on an insulating column? The answer is, if dome is not supported on insulating column, then all electric charge which would be collected on the dome surface will flow to ground. Therefore, the dome surface is insulated with insulating column to prevent discharge of electric charge from dome to ground. There are the two pulleys P1 and P2. These pulleys can be rotated with the help of electric motor. Over the pulleys, there is a belt, insulated belt. The insulated belt rotates as the pulleys rotate. What is the use of this insulated belt? It has very important use. That is, the belt rotates as the pulley rotates. This belt acts as a conveyor belt. Conveyor belt means what? Conveyor belt is one which physically carry the object from one point to another point. Since this belt carries the charge from one point to another point, therefore this belt can be called as a conveyor belt. This conveyor belt carries electric charge from bottom comb. There is a one device called comb. So it carries the electric charge from bottom comb to hollow metal sphere which is present at the top. I already told you that this metal sphere is called as a dome. A and C are called as brushes or comb. Bottom comb A, also called as spray brush, and top comb C, also called as collecting brush. These brushes have sharp metal spikes. The sharp pointed surfaces can collect more dense charges compared to plain surfaces. The purpose of brush A, that is spray brush, is to collect more charges and throw these charges on the moving bed. Therefore, for more charges to be collected by the brush A, the spray brush is made by using sharp metal spikes. Spray brush A is connected to high voltage DC supply. This DC voltage may be more than 10 kV with respect to earth. It is connected to positive terminal of DC supply through high voltage rectifier, that is HVR. As the spray brush is connected to high voltage, so what is the impact of connecting high voltage to the brush A? Due to high voltage, intense electric field is created at the spray brush, and this electric field ionizes nearby air. This process is nothing but called as a corona discharge. Due to this corona discharge, electric charges produced, and these electric charges flow from spray brush to conveyor belt. That is, due to corona discharge, a wind of electric charges produced which are directed from spray brush to moving conveyor belt. These electric charges flowing from spray brush to conveyor belt, they fall on conveyor belt. As the conveyor belt is moving, so charges are carried from bottom to top. At the top, there is a collecting brush ready to collect these charges from conveyor belt. Graaff generator consists of a special device called as a discharge tube. This discharge tube acts as a particle accelerator. What are the particles we use? Generally we use protons or deuterons. These particles can be easily accelerated in the discharge tube. So discharge tube acts as a particle accelerator. The top end of discharge tube, there is an electrode. This electrode is connected to dome. As the belt rotates, the charges are carried by the belt into hollow sphere, and there is a continuous accumulation of charges. As the electric charges always accumulates at the outer surface of hollow conductor, all the charges collected by collecting brush, these charges get distributed on the outer surface of the dome. The electric charges from belt, collecting brush and dome should not go into the surrounding air. To prevent these charges going into surrounding air, the entire arrangement is enclosed in a large steel vessel. And the second one, entire arrangement is filled with mixture of nitrogen gas and freon gas under high pressure. Now the big question, the question is why we are using mixture of nitrogen gas and freon gas under high pressure. So the first reason that we know that in Graaff generator large amount of charge is accumulated on the surface of the dome, and a very strong electric field is produced, and this strong electric field can ionize the surrounding air. To avoid that, what we are doing, we are filling the Graaff generator, the space between the steel vessel and the Graaff, we are filling a mixture of nitrogen gas and freon gas. This is the first reason. And the second, there may be the electric breakdown and there may be the leakage of the charges. So this mixture of nitrogen and freon gas will prevent the sparking and leaking of charges into surrounding environment. So these are the reasons why we are filling the space between the outer chamber and Van de Graaff with the mixture of nitrogen and freon gases. Now finally, let us talk about working of Van de Graaff generator. Electric motor is switched on, pulleys start rotating and conveyor belt is set into motion. This is supply given to spray brush, positive charge sprayed on the conveyor belt. The conveyor belt carries this charge in upward direction. These charges carried are collected by collecting brush. These charges are sent to dome. As the dome is hollow shaped sphere, therefore these charges move to outward surface of the dome. As the belt keep on moving, more and more charges gets collected on the outer surface of the dome. As the more and more charges gets accumulated on the surface of dome, its potential also rises. As the dome is connected to electrode I in the discharge tube, so potential of the dome and potential of electrode, they become equal. As the potential of dome is very high, similarly because of it is connected to the dome, therefore the potential of electrode in the discharge tube becomes equal to the potential of the dome. Therefore the potential of the electrode is equal to potential of the dome, and potential of the electrode is very high. Now we introduce proton into the discharge tube or accelerating tube. Both the names are same. Accelerating tube or the discharge tube. As soon as we introduce protons or deuterons into the upper part of discharge tube, these protons are repelled by electrode and they get accelerated in downward direction. And why they are moving in the downward direction? Because of at the top end of the discharge tube a very high potential, and the bottom end of the discharge tube is connected to the ground. It is earthed. Therefore these protons gets accelerated in the downward direction. Then these accelerated particles, because of fall of great potential, the top end of the discharge tube is very high potential and the bottom end of the discharge tube is grounded, is earthed. Therefore there is a very vast potential difference between the two ends of the discharge tube along its length. It is also called discharge tube or it is also called an accelerated tube, both on the same. So these accelerated particles acquire very high energy of the order of 10 million electron volts. Then these high energetic accelerated particles are directed so as to strike the stable nucleus, so as to strike the nucleus of given element. As soon as these particles strike the stable nucleus, we get unstable nucleus, we get disintegrated nucleus, we get radioactive element. Van de Graaff generator is used in nuclear physics, involving experiment to study nuclear structures, producing different radioactive elements, isotopes, to study nuclear reactions and to study nuclear disintegration. So in this video we have learned what exactly the Van de Graaff generator, how it works, and what are the different parameters and how we achieve the high energetic particles. How was the presentation? Please let me know and meet you again with next video. Till then, wish you good luck, all the best.